Here are our solutions to homework set number 5 for ECE 376 Embedded Systems. This homework set looks at using stepper motors, NeoPixels, and analog inputs with a PIC microcontroller. Now the project to work on is totally up to you as long as it uses those three features. What I did is I built an egg timer. So here's what it does. I've got the time I can adjust with the analog input. Turn this knob that changes the voltage on port 8 pin 0 and lets me input a time. When I get the desired time, I then hit button RB1. That will turn the stepper motor. That's your 0 position. It then goes to 180 degrees in 9.65 seconds. As the stepper motor is turning, the lights turn on. Once they're all the way on, it waits for 1 second, then resets. If I change the time, like let's make this 16 seconds, it will do that entire motion in 16.95 seconds, just changes the time between steps, time between the lights going on. So this would be kind of like your egg timer. Set the time, hit the button, and with the analog input, it remembers the time. So to do that, I'm going to do that in 2 steps. First, get the stepper motor to work. Start out with the requirements. So the input is the push button and the analog input. Output's the stepper motor, and part 2, the NeoPixel and the LCD display. And the relationship. So I turn the button, the voltage goes 0 to 50, or 0 to 50.0 seconds. Start with RB1. The stepper motor then turns 180 degrees in T seconds. The display goes from 0 to 100% in T seconds, waits 1 second, then repeats. To get that to work with the stepper motor, when I first started was with the sample code on Bison Academy for the stepper motor, added in sections. I first want to see, can I get the analog input to work? So this part initially was not in there. I just wait until I hit RB0 and read the analog input, display on the LCD, kind of like this. Display 0 to 50 on the LCD display as I turn that knob. That's the little test routine that reads the LCD display, or reads the analog input, displays it. Once that works, add in the next part. When I hit RB1, I now have my number 0 to 50. I want the stepper motor to go 100 steps in that time. So take the total time divided by 100, that's my step size. That'll be my wait milliseconds at that long. Steps, the time in milliseconds. Starting from 0 and 0 steps, keep going until I get to my desired time. 1 step is this many milliseconds. Add that to milliseconds. And send the stepper motor code to port C. You can kind of see that over here with the lights. Here's the 1248, 1248. That's the stepper motor stepping. Once I get to the end, well, that worked. Once that works, add in a 1 second wait. And go back to 0. Go back to 0 at 10 milliseconds. So this is the 1 second wait at the end. And then goes back to 0. So for validation, again, kind of check the different parts. The analog input works. This starts the timer. Try a couple different times. 10.85 seconds was actually 11.69. 20 is 21. Measured with a stopwatch. Close. Timing is actually a little bit off because the looping ignores everything outside of the wait millisecond routine. That also takes some time. Next, I'll add the NeoPixels. So to do that, I add a subroutine called bar graph. I tell it what percentage, 0 to 100, I want to have turned on. I am then going to define a 16-element array because I have a 16-element NeoPixel. The first N lights are turned on, otherwise the rest are turned off. I'll then display all 16 NeoPixels in that color. and that gives you the final code. So at that point, where is it? I turn on this bar graph section of code. And you have the bar graph being turned on from 0 to 100%. Once it gets to the end, it goes back to 0. I'll do that one more time with the lights out so you can see it better. Let's speed it up a little bit. Make the time 8 seconds. Waits 1 second. Goes back. So that is homework set number 5, using the analog input, stepper motor, and NeoPixel with a PIC microcontroller.